So in this video I'm going to tell you about converting between compound measurements. And before we start today's video, as always, if you have any questions with this video or you have any question about another topic, please just leave it in the comments below and I'll get around to answering you. So before we look at compound measurements, before we look at those units, first we need to be happy with our singular units, so units that just have meters or grams. So I've got some questions here for you guys to have a go at, and you need to be confident with these before we move on to looking at combining them. So pause the video and have a go at these, and I'll show you the answers. So hopefully you managed to get all of those right, and if you did, let's move on to looking at what happens when we start combining these units. So Usain Bolt set a world record for the fastest 100 meters. He did that in 9.58 seconds. So we can work out his average speed across those 100 meters. And we do that, hopefully you know this, by doing our distance divided by our time. So it would be 100 meters divided by 9.58 seconds. Now you can see that obviously we get a number in this fraction, this 100 over 9.58, but our units also change. We've now got meters divided by seconds. And so what we write that as is meters per second, and this is the unit for speed. Now this obviously isn't a unit by itself, it's not just a singular unit, it's now a combination of two. So if we work this out numerically, you can have a go at doing this, we get 10.44 meters per second on average across those 100 meters. But what about if I wanted to compare, say, his speed to the speed of a car? How fast is he? Well, normally we measure the speed of cars in kilometers per hour, or miles per hour, but for the ease of our calculations, let's use kilometers. How do we go about converting this 10.44 meters per second into kilometers per hour? So let's write this out first. We've got 10.44, and very important, let's keep these units on this side, meters per second, and then on the other side we're going to change those units and also change this number depending on what we do next. So let's first convert seconds into minutes. That's closer to hours. So in order to convert seconds into minutes, I would have to multiply by 60. Because if Usain Bolt can do this many meters in 1 second, then he's going to be able to do 60 times that many meters in a minute. So now my units have become meters per minute. So if we work that out in the calculator, that's 626.4 meters per minute. And now let's convert these minutes into hours. So if he can do this many meters in a minute, he's going to be able to do 60 times that many meters in an hour. So once again, we're going to have to multiply by 60. And now my units aren't meters per minute, they are meters per hour. So if Usain Bolt kept up his speed for a whole hour, he would be doing, working it out in the calculator, 37584 meters per hour. Just move this up a little bit. So now that I've got the correct hours here, I've got hours after my kilometers, I need to convert my meters now into kilometers. So if in an hour he's doing that many meters, well, there are a lot more meters in that same period of time than kilometers. So I'm going to get a smaller number when I go from a small unit to a big unit. So instead of multiplying by my factor, I'm now going to be dividing this number by 1000. Because that is the factor from converting meters into kilometers. So now I've finally got my correct units, kilometers per hour. And if we work this out here, we get, well, he does about 37.6 kilometers per hour. Now that's pretty fast. So we've gone from meters per second into kilometers per hour. So another question that you might get might look something like this. So we're told that this wooden log has a mass of 700 grams and we're given its volume, which is 1,600 centimeters cubed. And we're also told the density of water and we're asked, does the log float? Well, for something to float in water, it has to have a density that is less than the density of water. So what they're asking us to do here really is compare the density of this wooden log with the density of water. So to work out density, we do mass divided by volume. So let's do that here. We've got 700 grams divided by 1,600 centimeters cubed. And so that there is equal to 0.4375 grams per centimeters cubed. So once again, we've got this compound unit here. And if we try to compare that now with the density of water, we can see that these units aren't the same, so we're not quite ready to compare them yet. So once again, let's go through the same process. We've got grams per centimeters cubed here. So first of all, let's get this down. Let's convert from centimeters cubed into meters cubed. So if 1 little centimeter cubed of this wood weighs this many grams, then I'm going to have lots and lots more of these grams in a whole meter cubed of this wood. So this number is going to get much, much bigger. And I don't know if you remember the factor we convert by, but that is 1 million that we're going to have to multiply by. So if we do that, our units will become grams per meter cubed. So we've got the correct meters cubed now at the end of our units. Now we need to convert from grams into kilograms. So if we multiply by 1 million, this is what we're going to get. So now grams per meter cubed. So this is how I recommend that you lay out these questions. So converting one little section of the unit and thinking it through as you go along. So now converting from grams to kilograms. Well, this is a smaller unit going to a bigger unit. So in the same meter cubed of wood, I'm going to have less kilograms than grams numerically. So I'm going to be dividing. So the factor between kilograms and grams is 1,000, so I'm going to be dividing by 1,000, and that's going to get me the correct units of kilograms per meter cubed. Just work this out numerically now. We get 437.5 kilograms per meter cubed. So we've got the units the same now. We can compare the numbers. Obviously, for 437.5, it's less than 1,000, so it is less dense than the water, and so the log is going to float.